because we have to think about more than one strategy in each one, okay? Or maybe something slightly different. So this first one, now this is an example, and there's more than one way you can begin, but this is an example where it's very natural to think both substitution and by parts, and we will in fact use both. But if you first think, and this is always my first strategy, I look for what I call an obvious substitution. We see an inside function, a multiple of its derivative. Well, the derivative of the inside function is 2x, and we don't exactly have a multiple of its derivative. We have x cubed, not like 10x or something like this. So maybe you think substitution is not the way to go, and you think, well, okay, I'll start by parts, right? Now, this is also problematic to think about doing one or the other technique, because in this example, if we follow this rule of thumb, what do we have? We have algebraic. And if we follow this exactly, it would tell us that u should be x cubed and dv should be e to the x squared dx, right? Then we differentiate and we integrate. Do you see we have a problem? E to the x squared is one of the functions that does not have an elementary antiderivative. So we're not going to be able to write this, okay? So this is an example, and this is one reason I like this example, where Liate fails, okay? If we try to use it exactly. So this is wrong. Maybe I'll write this, and then I will do something else. But we can do this integral. We can do this. And it goes back to what I first said about it. I look at it and I see substitution. So let's erase this, because Liate, which is a wonderful rule of thumb, gets us into something that we can't integrate here. So let's change. I will begin by parts. But if I think looking at this substitution, and this is what I started with, u is x squared du 2x dx, which means I can integrate this. Oops. This is something I will be able to integrate, and then, well, I can do this, x squared. Now u dv is the entire integrand. I differentiate, then I need to integrate. And maybe because this is an important step, I will come to the side and compute this integral in green. Pardon me. So this integral, this is side work, x e to the x squared dx. Ooh. U is x squared du 2x dx. We have x dx, which is 1/2 du. Okay. This becomes an integral e to the u times 1/2 du. We get 1/2 e to the u plus c, which is 1/2 e to the x squared plus c. And in fact, you can check this. Just differentiate this. It's a chain rule, right? And we get exactly x e to the x squared. So I'm going to keep this on the board. We will put it in one big box. Now, if I return to this problem, this gives me that v is 1/2 e to the x squared. Okay? Now I perform integration by parts. uv minus the integral v du. So this black integral, maybe I will go back to black for this, is x squared over 2 e to the x squared minus the integral. Well, when I multiply these two, I just get x, e to the x squared dx. And guess what? We have, this is one reason I came to the side, left it on the board. So this is x squared over 2 e to the x squared minus, right here, 1/2 e to the x squared, and then finally we have plus c. This is our final answer here, okay? This is a great problem because we have both substitution and by parts, but we really had to think. And it could be, as I began it, it was a little bit of trial and error to get the right u and dv. Here's another problem. Now, pardon me. If you remember the lecture video on substitution, well, it was a review of integration day. It was our very first day of the semester. We did, maybe I will just mention this. So we had this integral, and I won't redo the whole thing. I will just remind you, we had sine square root of x divided by square root of x. And this was substitution. This was our very first day. Okay? And this one is, well, it's a straightforward substitution, meaning you see an inside function, you see a multiple of its derivative. This is what I refer to as a subtle substitution, because when you look at it, you see an inside function, but you do not see a multiple of its derivative. Okay, so I will erase this. You can go back and watch that video if you forgot how it went, but let's do this one. U is the square root of x. Du, well, you take the derivative. Now you might think there's no way I can do substitution here because what do I have handed to me in my integral? I have just dx. Now, for the moment, let's multiply through. We have 2 square root of x du. Now, do not think I'm about to put this in my integral. No, I will not, because you know I only write an integral entirely of x, or I write an integral entirely of u, and I would never put this here as it's written. It would mix u's and x's. But here comes the beauty of this problem. Look, u is the square root of x. So this literally is 2u du. Okay? Now I can replace everything in my integral with something of u. I have sine of u. And then I have times 2u du. Okay, maybe I should put a box around this work because I'm definitely not done here. Now, stare at this for a few minutes, and what does it tell you? It tells you liate, integration by parts. So this one also, to compute this integral, we have to do both substitution and integration by parts, just like in the last one. That's why it makes them both a little bit more challenging than ones we have seen. Okay, well, I'm not going to call it u and v because I already have a u in this integral, so maybe I'll call it w and v. If I follow this and it works here, looking at this integral, I have a algebraic. So w will be 2u, and then dv will be sine u du. Then I differentiate to du, and I integrate. We integrate sine, negative cosine. Okay, and then I have, well, it's going to be wv minus the integral of v dw. I don't know if you hear it, it's thunderstorming outside. And it's very loud from my window, so hopefully my microphone, you hear me more than the thunder. Okay, this is minus 2u cosine u minus the integral of 2 cosine u du minus 2u cosine u is going to be, oh, I left off a minus sign, excuse me. There's a minus, and then this is negative, minus 2. Okay, this now becomes a plus. And when we integrate the cosine, it's positive sign. So we have plus 2 sine u plus c. Now, we're not finished, right? Because look, just like with any substitution problem, and this fundamentally started as a substitution problem, when you have your antiderivative, that's a function of u, you must go back to your original variable. So here we have minus 2 square root of x cosine square root of x plus 2 sine square root of x plus c. And this is our final answer. This, just like the last one, in my opinion, are quite fun. You really have to think to get yourself down the right path. Class, we just saw we were integrating sine square root x dx, and my second to last, so the details we just discussed. My second to last step had this, where u was the square root of x. But then, and hopefully you caught this, I didn't copy my minus sign, so the correct answer is minus 2 square root x cosine square root x plus 2 sine square root x plus c. This minus sign was left off, and my apologies, but this is our answer.